We start with a short exercise. We want to find a vector orthogonal to 3, 2, negative 4. Now, what does it mean for two vectors to be orthogonal? It means their dot product is 0. So what could we fill in here that would give us 0? Of course we could fill in all zeros, but that doesn't count. Okay, it's a non-zero vector whose dot product with this vector is 0. Okay, well, all we have to do is find a vector such that 3 times this component, 2 times this component, and negative 4 times this component adds up to 0. That shouldn't be too difficult. In fact, we can choose any one of our components to be unknown, and the other two components will be determined by the value of that unknown. So we'll determine the value of that unknown. So in this case, I said, okay, let's just say the first component is 24 and the last component is 32, and the second component of this vector is aardvark. Okay? So if 3, 2, negative 4 dot 24 aardvark 32 is going to equal 0, then 3 times 24 plus 2 times aardvark minus 4 times 32 has to equal 0. Well, this is just what? 72 here and negative 128 here adds up to negative 56, plus 2 times aardvark has to be 0. It follows that aardvark is going to be 28, and you can solve that very easily. So we usually wouldn't use aardvark, we'd use x or c or something like that for the variable. But I chose aardvark just to say it doesn't matter what you call this variable. If these other two are not both 0, we'll always be able to solve for this one. Well, that is, as long as this times this plus this times this is not 0, we'll be able to solve for this. I'll take it back. As long as one of these two is non-zero, we'll be able to get a vector. Okay, so 3, 2, negative 4 dot 24, 28, negative 32 is 0. These two vectors are then orthogonal. Okay, other vectors orthogonal to 3, 2, negative 4. You can make them up. You can find as many as you want. I just say that these three are, and you can easily verify dot product of this and this, dot product of this with this, dot product of this with this. They're all 0. Okay, now we're going to come over here and start talking about orthogonal basis and orthonormal basis for a vector space or for a subspace.